This is a very complex pi configuration. 30 inches voided splice pi. The splice is mechanical splice. The data is collected by others, and you can see that the beta is quite bad because of the voided as well as the splice.
We are going to process the data using GPC. Now, when you scroll the mouse down or use the paste down like this to view different blows, the scale of the graph is jumping up and down to match the maximum range. If you don't want that, you can just change turn off the auto scale and put a number here that you think will cover most range of all the blows. Go back to blow number 1 and just paste down now. Keep pressing the paste down, different blows. So the wave up, the original wave up, has a lot of bump because of the different voided sections. Rise up when impedance increase, drop down when the wave encounter the void, and this is the supposed pi tau. So when you view like this, it's quite difficult for the user to evaluate the pi resistance as well as the pi integrity. It's very difficult to evaluate pi integrities of the pi. So in GPC, we have a very advanced features that when you view only the simulated wave up, which is called WU0, the user will be able to, let me go back to blow number 1, turn off the raw wave up, turn on the simulated wave up. So now the user, much easier for them to evaluate the pi integrity. So this is the splice locations, and you see that there is some small reflections because of the mechanical splice gap there. And the wave up is quite smooth from the top of the pi to the toe of the pi. And it's very easy, again, very easy to evaluate the skin frictions as well as the reflections from the splice. The beta here is based on the simulated wave up. So the beta here makes much more sense in our GPC. So we are going all the way down to the end. The reflection from the splice is a little bit larger now. Pi has some unloading skin friction here. As you can see, the velocity is negative twice before the 2L over C. So this is 2L over C. The value here is 2L over C after the peak, after the maximum force. So velocity is the blue here. It became negative twice before the valley. So that is some indications of pi skin friction unloading. This is 21 days. The increase here is the 21 days wait. So the pi is going from here, encounter a very hard layer here. So let's look. This is soft layer, and this is hard layer. Soft, hard. So you see the wave up, rise up, indicating a much higher toe resistance between this and this. So much higher toe resistance here. And then the pi driving stop here, where the end bearing or toe resistance reduced, and there's this is right around here. That's the 21 days read drive. So in a 21-day read drive, it has a lot of skin frictions freeze or setup, a lot more compared to earlier low skin frictions, and here a lot more skin frictions setup. And you see this the reflection from the mechanical splice. So that is the 21 days restrike, and down here is just I don't remember, but it's just a few hours set check down here. Just a few hours set check, so the resistance doesn't change much here. But again, here is the soft layer, where very low end bearing, and this is a harder layer with higher end bearing. So at the 21-day restrike, in the beginning of the restrike, because of a lot of skin friction, it absorbs the tensile stress. So we see here, tensile stress drop big time at the beginning of the restrike. So before that, very high tensile stress up to 1.5 psi, and wait 21 days because of a lot of skin friction, it absorbs the stress, and this tensile stress drop big time here. In terms of beta, so using GPC, the beta is most of the time the beta stay around 90%, and the beta there is either detected because of the unloading skin frictions, which is not a real beta, or because of the splice. So let me see. So let's see. So here is the beta 89% because of the reflections of the splice. But in general, beta here is about 90%, and the pi is perfect. Signal matching for this complex configuration is very, very difficult. In a pi with high resistance, it will be a little bit easier to match. So in this case, this is the 21 days restrike, the blow number 2, a 21-day restrike, and a little bit easier to model. So the pi has a mechanical splice here. So let's go from top to bottom. So the gauges is here. This is voided sections, and this is the solid section. Taper up, solid. Gap in the mechanical splice. Solid section, taper down, void. And then taper up, solid. So that is the configuration of this pi. And the gap is at location of the splice here, which is 67 feet. The pi is also modeled by a tension slack at the same locations. So at this blow, the restrike blow, it is mostly skin friction. So the skin friction is almost 900 kPa, and bearing is only 41 kPa. So almost 900 kPa of skin frictions. And here you can see the simulated WU0 as well. It go out of the graph because the magnitude is too large. There's two ways you can see everything. You just type a number here, and then you can see everything. So this is the supposed pi toe, a lot of skin friction from 0 up to the toe of the pi, and this is the splice reflection from the splice. Another way to view is you can earlier you can just go jumping between different tabs, and it will auto adjust with the auto scale. This is a signal match example for blows during the 1 hour set checks. So this blows has very high end bearing, 665 kPa of end bearings, and only 220 kPa of skin frictions. total 906 kip of resistance. So when the pi has a lot of total skin frictions like this, it is also relatively easy to do signal match. The more skin friction, the easier to do the signal match for this complex pi, actually. But this one is still relatively easy to do signal match. But for a blow in a soft drive with this complex pi with 7 sections like this, then it would be very, very difficult to have a good match if the blows doesn't have much resistance. So this pi has a mechanical splice here, as you see earlier, and a tension slack was modeled at that location as well. The tensor limit force at this slack vary from blow to blow, so it's not a constant. So this value will vary depending on the hammer energy input as well as the skin friction distribution. So the match here is pretty decent. It's not quite good, but pretty decent. And if I remove this slack, you see that the match is pretty bad, mismatch here at the toe. If I click previous, see the previous save information. When I click WU0 for the simulated wave up, I don't see anything yet. So note that if you don't see the wave up simulation, then the beta is based on the raw wave up, and as such, the beta is only 59%. So to refresh, you hit F2, and when you hit F2, you see these wave up simulation. Let me turn off so you can see it clearer. So this is the toe. This is a big reflection from the splice, and the beta is 88% from around the splice location. So if this pi is going to be restrike in another 21 days, for example, then there's a possibility that you will see much more gain in skin frictions. It will not only 200 something kips, it may become 700, 800, or 900 kips of skin frictions in another 21 days of wait.